Thank you. And the coolest part about a many-to-many relationship, a lot of the times, which you'll see in this case, is when you're connecting two different models together, and it's a many-to-many, that's when we define the has many through. So what you'll notice today is we have our hikes that has a relationship with two different objects, and we have the ability to combine the relationship between a person and a mountain and say, hey, not only can a person have many hikes, but because hikes is keeping track or already has a relationship with a mountain, a person can also have a relationship with a mountain. And we kind of like explored this topic in the beginning. I know one of you mentioned like the forest idea, like if a forest can have many mountains, and hikes also has a relationship to a mountain, then technically a hike can have a relationship with the forest too. So they're all interconnected. And it's cool to kind of see that in a real life example too. Sweet. So that's kind of where we're going to pick up from today, just reviewing the one-to-many relationship and then transitioning into a many-to-many. And is there anything that's still hazy or you want to go through and add on to our SODATs for lecture today?
I think for me, it's trying to figure out which class creates something and which class stores that relationship. Yeah. So you have that one source of truth.
Oh, we're going over the one-to-many relationships and belongs to today?
Yes.
Okay, good.
I'll review that with mountain and hike, and then we'll also implement person and hike, so you get to see an example of that.
Okay.
And if you still have questions that are come up with regarding that, feel free to ask at any time. We'll go through it. All right, and then how to represent a has many and belongs to. All right. Anything else people want to add to the list?
One question is, this is in our class, like our specific class GitHub folder?
Yes, this specific lecture, I just created the intro to many-to-many. But the code for this is going to be, if you already have the Git pull for it, this is off of the, which one is it? Can I do Git pull? I'd have to double check. I feel like there's a O2 intro to one-to-many. That's going to be the one. I don't know why I can't find it here. Yeah.
Thanks.
Yes, it's uploaded to the main repository. I think I might have forked this, so I have a fork of my own copy on this computer. But yeah, it'll be the one-to-many one, and you can build off of it from there. All right, any other questions?
Quick thing, and sorry, maybe we might be able to just handle it now, but you mentioned earlier models and classes in the same sentence?
Yes.
I was wondering if that was it. Like if you're saying models and classes, like if is a model like a collection of classes, is a model, could a class be considered a model? Like, we could talk about that a bit.
Yeah, so models and classes mean the same thing. A model is a class is a model. Once we start introducing like tables and things like that, there will be like more conventionally, you'll hear classes referred to as models in like the greater domain of object-oriented programming, but they mean the same thing.
How far different
that's a good question.
Module in class?
Oh, module. Oh, is that what you were saying? Module or model?
I said module.
No, that's a separate.
Yeah. So modules are definitely different from classes in Ruby. And this kind of goes into inheritance in Ruby and sort of like also metaprogramming in Ruby too. But you'll notice like once you start looking at inheritance in Ruby, Ruby does not have multiple inheritance. So if there's common properties between multiple classes, you can't say one class is going to inherit from more than one thing, which is something that's common in other languages, but not Ruby. And to get around that, Ruby has another type of object that you can create called a module. And a module can have multiple classes inside of it. So typically, if you're like, hey, I want to have one object with multiple classes because they behave pretty much like a single class, or a single module needs to have all of these properties, you'll make it a module. And typically, it'll have like as many classes as you want to create inside of it. And you can take this module and use it in any other Ruby class. So you can have a Ruby class inherit from that whole module that has like multiple classes inside of it.
Okay, that makes sense. So when you're talking like inheritance, you're talking like parent, child, grandchild, first cousin, that kind of thing.
Yep, first cousin. Yes, this is like cousin family, aunt family, or something like that. We never like build out modules in like mod 1. However, we will be using a module eventually introduced as a framework in our Ruby project next week. So you're gonna get practice with how to use a module and how can you call classes within that, create instances. It's pretty cool.
Okay, awesome.
Yes, good questions. All right, anything else? So let's get started. All right, so I typically like to start out with at least a visual so you can get kind of a visual of what we're doing and what's going on. This is what we've done so far. When we have our 2 models that we've determined so far, we said, hey, we're gonna define 2 different classes. There's a mountain class and there's a hike class. And these are just 2 separate classes that we built out in the beginning, and then we defined a relationship between them. That's where Ruby relationships get super powerful, and Ruby programs get powerful. Rather than just having multiple classes exist on its own, once they start interacting with each other, we can treat it like a real world object and build apps out of it. And we'll be exploring, we'll probably take a look at some other site like YouTube or maybe even Learn. And you can actually see all of the different parts that make up the website, and you'll get some practice looking at a real world application and trying to figure out the models for it, which would be super fun. But in this case, we have our hike and we have our mountain, and we defined a mountain has many hikes and a hike belongs to a mountain. Initially, we said, hey, a hike belongs to one single mountain, so I'm going to keep track of all of the mountains in here. And we also said a mountain has many hikes, so we can keep track of maybe like a collection of all the hikes that this mountain has. And we made an instance variable. And this is where we kind of defined the actual connection between the 2. Unless I'm storing the actual instance of that whole object inside of the classes, there is no connection between them in code. I know that a mountain has many hikes. Hike knows it belongs to a mountain, but without this association, there's no connection between them. So when we say 2 different classes are being associated, 2 different classes have a relationship with each other, or referencing each other, what we mean is we have these actual instances that are being passed in. And we started kind of looking at the setup that we had here. And when we have an array of hikes that's being stored in the mountain class, and when we have hike already keeping track of a mountain because hike belongs to a mountain, this kind of brought up the question of, there's 2 different places in our program now. Where is my single source of truth? Because mountain is also keeping track of its relationship with the hike, and hike is also keeping track of its relationship with the mountain. So at this moment, there's no single source of truth. There's relationship being represented in both classes. And this also kind of ended up being in that infinite loop where we saw you can call like mountain.hike.mountain.hike.mountain.hike, and go on forever and forever and forever. So that also creates some inefficiency in how we're keeping track of data inside of our class. So that kind of led us to that rule, which we will follow kind of moving forward in mod 1, which is when you're representing the has many relationship, you are never going to store that collection or store that array in that parent or in that has many class. So mountain, oh yeah, go ahead. I think I heard a question. All right, so mountain is never going to have the responsibility of storing an array of all of the hikes. that it has. And now it's kind of like, all right, well, how the heck am I going to find out all my hikes? The only place that has that information available now is the hike.all. So Mountain will always have to communicate with the hikes class to get information about the relationship between a mountain and a hike. That is how we defined our one-to-many relationship. This is the representation of how a one-to-many has many belongs to relationship is going to be. I'm going to pause there for questions.
So for the mountain, oh, go ahead.
Go ahead, Nathan.
So I was going to say that's when you could refer from the mountain. So I'm in the mountain class, and then I want to have a list of all the hikes.
Mm-hmm.
I would ask the hikes class to return all the hikes that it has for the instance of the mountain.
Yes.
Is that correct?
That's
so
correct.
Within the hikes class, I would have a method which would just be shoving on the hikes for that instance of the mountain.
Let me see.
And that's what the mountain would be referring to.
Yeah, so that's exactly correct. In our mountain class, to get hikes, we will talk to the hike class. Oops. And in hikes, we will have a method to keep track of them. I think that's what you mentioned, to keep track. The mountain. It belongs to. And if we're talking about this method, that's keeping track of the mountain, which method is that going to be? Like, where are we going to find all of the mountain information in our hike class?
Add all.
A class variable.
Yeah, exactly. This add all is super powerful and important because every single class has information about its own instance. We will always be talking to that add all to get that information. I don't know why this is like being slow. Without this add all, we will not be able to, mountain would not be able to talk to hikes, and hikes would not be able to talk to mountain. I don't know what happened. All right. Yeah, thank you for that clarification.
So, other question. Is many to many the same thing as has many through?
Many to many is the same thing as has many through. Yes.
Cool.
And I'll like introduce that. I don't know why it's not letting me highlight add at all. I just wanted to bold it. Okay. But yeah, we'll kind of introduce that once we have person and hike built out.
And
sweet.
In this case, the add at all that you just wrote, that is using the mountains add at all or the hikes add at all?
Oh, that's a great question. So this is specifically the hikes add at all. So this add at all is going to come from the hikes. And when you're trying to figure out which class do I need to talk to, we said we're not storing arrays or collections in the mountain class. So mountain only knows about mountains. The only thing that's keeping track or being kept track of in this add at all for a mountain is the name, elevation, distance, longitude, latitude, location of that mountain itself. It knows nothing about hikes. Hike, however, because it belongs to a mountain, all it needs to do is when I get created, which mountain am I on? And it keeps track of that instance variable. So hike keeps track of information about its own world, and its own world happens to be also containing the at mountain because it needs to belong to a mountain in order to exist.
And then you could have, I mean, you might have an instance where this is something I was thinking about yesterday, because if you got a hike, a single hike object that belongs to a mountain, it's located on a mountain, but then it could have multiple people that have made that hike, but then each person might also have multiple hikes that they've made. So then you've got, okay, that makes sense. Okay.
Sundari, can you repeat a little what you mentioned before? Was that something about mountain, like has no idea of what is happening inside of hike, but hike Can you just repeat that?
Yes, and I'll show an example with the add at all also. So in this case, when we're talking about, all right, I need to be able to write a method called hikes to get information about a hike from the mountain class. At this moment in time, in our add at all for mountain here, it only knows about all the instances of a mountain that's been created. So it has maybe like 10 different mountain instances, for example, and they each have their own name, elevation, distance, longitude, latitude, and location, and that's it. It's not keeping track or storing any information about a hike. However, when we take a look at the hike class, when we create a hike, we say, because hike belongs to a mountain, I'm also keeping track of the one instance of the mountain that I'm on, which is why in hike.all, it's maybe we have like 10 different hike instances. I have an instance of a name, and I also have an instance of that mountain object that I'm on. So now hike.all also has mountain objects, and that's what's defining the relationship between them.
Okay, thank you.
So
Yeah.
in the method, if you did hikes.all, it would also store
Mhm.
that mountain data.
Yep, exactly, because of this line here.
Cool.
Yeah, at this moment, this is the only line that's connecting. Oops, no. Gonna not like move anything. This is the only line that's connecting the hike to the mountain. Otherwise, they will not know about each other.
It's not necessary that the mountain inside the hike will match to the mountain inside the mountain class.
It is necessary if you're trying to get data.
Yeah.
Yes, but other than that, this mountain is going, well, I guess like this mountain does have to be an instance, some instance from the mountain class, because we need to pass it a mountain object here.
So is hike a class?
Hike is a class, yes.
So we're taking the information from mountain and putting it into hike.
Yep.
So
Exactly.
I talked about this earlier, but I'm sure we'll learn about it next week. Could you do class hike less than sign and then mountain to put all the information from mountain into hike?
So that would be, when we do inheritance, we are saying a hike also is a subset of a mountain, but in this case, we're defining hike to be a completely separate class. So if we build it out so that a hike has the exact same properties, then we can say that. But not every single hike is going to have an elevation or the same distance, or it might have the longitude, latitude, but since the properties are going to be different, it's just going to be completely separate from a mountain.
Okay, thank you.
Yeah, that's a good question though, because when you design it, it is possible that you can say a hike is a child of a mountain. In this case, it's going to be separate.
So just to make sure that I understand, the at all is what keeps them connected.
Right
inside
now,
of hike.
Yes.
Okay.
At all inside of hike is what's keeping these two connected, because hike has this instance mountain inside of it.
Okay.
I think it'll get easier to understand once we code it, right? Because then we can see what's going on.
Yeah. Yeah, well, also, I'll go through the example that we built out for hike and mountain. But yeah, any other questions on the visuals? Sweet.
We might be getting into this with inheritance, but like back to like if every hike belongs to a mountain has multiple hikes. Every hike belongs to a mountain, but then if you have an instance where, if you ever have an instance where a hike could belong to multiple people because multiple people have done that same hike, and then each person could have done multiple hikes, you'll wind up with that same infinite loop in an instance thing. Would inheritance solve that? Okay, cool. Okay, awesome.
Well, I wouldn't say inheritance will completely solve that, because even with inheritance, you still have to set up the relationship between the two. So it'll be a little bit different, but the relationship and the convention will be the same. All right. Cool. Yeah, I put a timer and I'm gonna hold myself to it. So it's been 20 minutes. I'm gonna pause pause for maybe like, oh, I don't know. I'll pause for like 4 minutes. So let's meet back at 11:01, and then we'll pick this up again. So just take a break from the computer, stretch, get up, and I'll see you back at 11:01. But 20 minutes again. Let me know if 20 minutes is like too short or too long. Practicing Pomodoro today. Sweet. So those were some awesome questions on just getting clarification on one-to-many, has many, belongs to. And I know one of you mentioned the has many through relationship. Is it the same as a many-to-many? That's exactly the same for the has many and belongs to. So when I say has many and belongs to, that's exactly the same reference as the one-to-many. So we're talking about the same thing. Cool. Any final questions about the hike or the mountain class before we go take a look at the code that we have for this?
Wait, so you said that many to many. So many to many is the same. Is not the same as has many belongs to, but it is the same as has many through.
Yes. So has many and belongs to is the same as. Let me edit it.
One to many
is the same as one to many. Let me see if I can add a new box. This is great when it works, but it's too slow right now. But yeah, has many and belongs to is the same as one to many. And the has many through is the same as the many to many.
Cool. Okay, thanks.
Yes. All right, let us take a look at code. So that visual we saw between mountain and a hike, that's the domain that we have kind of gotten practice building out. So far, we have separated our concerns so that our hike class is in the hike.rb. Our Ruby file for our classes or model is going to be always singular, and I usually make them all lowercase. And we got all of our hike stuff in here. And our mountain has all of the mountain stuff. I had location in the other visual, but I'll just keep it as longitude, latitude. And we wrote a couple methods out, which we'll review, but we have the basic template for the mountain class. Let me actually comment this out because this should return the integer elevation. And then I renamed our sample.rb to console.rb. Conventionally, you'll see this file be referred to as the console.rb or the run.rb file. So if you see like run.rb or console.rb, what it's basically saying is we required all of the files and gems that we need at the top. And all of the instances that we create is going to go in here. And our mountain has 3 mountains that we've defined so far. So we can initialize a mountain. And just like we mentioned in the visual itself, we are not passing any information about a hike into this mountain initialization. All it's keeping track of is its own data, its own name, elevation, distance, longitude, latitude. And to kind of streamline our process, we have a method in our mountain class called add hike, and that handles adding the hike to that specific mountain. Another way that you might also see the syntax is saying hike.new and passing the instance of a tiger. This is a syntax that was a little weird to kind of get used to seeing. We're going through mountain.all and we're sampling through and passing in the hike name. And this was to get comfortable with the concept of self and how mountain can talk to the hike class and get access to the mountain information and also have access to the hike information. So let's take a look at add hike in here. And inside of add hike, all it's doing is taking in the hike name and it's creating a new instance of a hike. We have an idea that because hike belongs to a mountain, it needs to take the whole mountain instance rather than the mountain name or things like that. So we pass in self from the mountain instance to get access to that. And if we want to see what that looks like, I'm going to put a binding.pry in here.
Can you repeat that, please?
Yeah. Yeah, if you want me to go in depth at any point here, definitely let me know. So in our mountain class, when we create a new mountain, because mountain is not responsible for storing anything about a hike, it just takes in its own properties and attributes. However, it's a little bit different for a hike. A hike needs to have the mountain instance in order to exist, in a sense. So when we create a hike, we need to pass in a mountain. There are a couple different ways you can do that. You can definitely say something we've done is tiger equals hike.new. And hike takes in a name, so we will say point. This might lead to like duplicates, so I'll leave that. And the main part is you're also passing in tiger. So this is the location where I am connecting this hike that I'm creating to this mountain because I'm passing in that whole variable. So this also brought in the idea that in order for a hike to exist, we need to pass in that mountain. And this is exactly what's happening in our add hike method. So if we take a look at our hike method, we have our hike.new, except in this case, because you already are in that instance method for that mountain, you can pass in self. Both of these are ways that you should get comfortable instantiating or comfortable associating these two instances. So you should be comfortable doing both. The hike.new from console.rb, and sometimes also passing in self for the mountain. Or
is there a reason you would do one over the other?
Yes, so this would be entirely reliant on the deliverables that you're working on. So right now we built everything out from scratch. But if you take a look at one of the deliverables, I don't know where it is, it told us to build a method add hike that takes in a name and creates a new hike and adds it to the hikes collection. So in the console.rb, the hike.new is great if you're trying to make sure that it works and it takes in the mountain instance as you would expect. In this case, they wanted us to write a method for it. So we created a method, and that's the case where we pass in self because we need to have this method belong to a mountain instance.
Question.
Mm-hmm.
On console.rb.
Yeah, let me go back. Console.rb.
Wouldn't tiger equals hike.new point tiger overwrite the original mountain instance with a new hike instance that then belongs to the old mountain instance, but then would no longer exist? That's interesting, actually. And now that I think about that, I wonder what that would do.
This would fail if I did that.
Oh, it would just fail. Oh, right, because when it goes to enter the hike instance, that's so weird. That's so cool.
Ruby is not. Oh, whoops. Ruby is not smart enough to like say, hey, this is probably a mountain. No. So I accidentally overwrote the hike to tiger. And tiger now is a hike instance, and hike does not have a method add hike, which is why you're seeing this error here.
Oh, but tiger is now a hike instance. But what is go do tiger.mountain?
Tiger.mountain.
Now I want to know what that hikes mountain is pointing at, because the mountain instance no longer exists.
Can we not go down this rabbit hole though?
Yeah.
Sorry.
You said that we're adding tiger onto the end for what?
Adding tiger on the end for a hike. So in this case, tiger is still the mountain. So this will still work. It'll still be the mountain instance. It's just at this point it's overwritten, so you won't have access to the add hike. So it'll still work here.
Okay, that makes sense.
Yep.
Syntax question: why are we storing on each of these lines the variable psi, Pilchuck, tiger, bear, sunshine?
Yeah, that's just in case I use it later.
Gotcha.
So there's no particular reason right now. I usually just like to put this in a variable in case I use it for something else.
Okay.
Cool. Good questions. All right. But yeah, get comfortable using creating associations in the classes and in console.rb. So I usually like to show both ways. And let me. What was that?
If I try to add new hike.new with and I put something else, it's not tiger. Like
yeah, that's fine.
Will create new mountain inside mountain.
Create new mountain.
If I put instead of tiger, I'll put some Rainier, like this. What it will do to the mountain class? It will new mountain class, or I just have another mountain in hike class?
You'll just have another. So if this is Rainier, right now Rainier is going to be nil. But if you have another mountain, it's just going to create another. It's going to create another hike with that mountain association. Like Ruby's not going to be smart enough to know, hey, this mountain already exists. We need to write the code for that to kind of bound it.
So we would need to make sure that if we're adding a new mountain like Rainier, we add the mountain first and then add their hikes.
Exactly. Yep. In order for a hike to exist, that mountain needs to be there. That's exactly correct. All right. So that is the association between the hike and the mountain and how they're connected. And then I also want to show our hike.all. So let me done Ruby console.rb. Oh, I have. All right. I forgot I put a binding.pry here. Yeah, I forgot I put the binding.pry here. Yes, let's go over this. So in my add hike, I am in the mountain instance and getting comfortable like using self here. If I go into add hike, let's double check name. This is exactly the first name that I passed in from my console.rb, which is perfect. Anytime you see a deliverable or anytime we're associating a class with a class and you're building that instance method in here, we're going to create a new instance of that association. So right now, my mountain is saying I'm adding a hike and its name is going to be Bear Peak Out and Back. And a hike also needs to take in self. And self is always going to be the instance that called this add hike method. So if I type in self.
What is the deliverable?
Oh, so this specific deliverable is I'm creating a new hike that takes in a name and adds it to the mountain hikes collection. And this is intentionally a little weird because it says mountain hikes collection. This is actually being kept track inside of the hike.all array. So when I create hike.new, that mountain instance, because I passed in self here, is going to be added to hike.all. Pausing for questions.
Can you run an add hike right on a mountain real quick? Just run like tiger.add hike to see what it looks like.
Yeah. I can run this line. Hike equals hike.new. So we have our name, we have our self, and let's associate the two. When I say association, it's this line right here. I said hike.new, I passed it name, passed it self. And the result I got is my new hike instance, which is perfect. And it has two attributes. It has the mountain variable and it has the name variable. And the mountain, this association we know worked properly because this has the whole mountain instance inside of it. It's not just storing the name, it's storing the whole thing. So when we try to query and search for things inside of our hike class, it's going to have this mountain ID inside of there.
But outside of the pry, if you were just calling on the add hike method, you just write tiger.add hike and then the name of the hike.
Yes.
And okay, gotcha.
Yep.
That would do the same thing. Right.
That would do the exact same thing. And that's what we're doing in our method here. We're saying here it's mountain.all.sample. But in this case, if we say, I'll comment this out. If we say tiger.add hike, that's doing the same thing.
Okay.
Cool. And then I think we can say hike.all already. So we've done this a couple times inside of this binding.pry. But if I say hike.all from here, I get two hike instances that have been created so far. And technically there's two hikes that are at Tiger Mountain right now. One's called Poo Poo Point and one's called Bear Peak Out and Back. And this is how hike.all is keeping track of all of the mountain instances. and that's what's connecting those two together. All right. Any questions so far? I'm gonna do like a heat check, thumbs up if you're like, I feel good, sideways if you're like hazy, good but hazy, and down if you're like, I still don't understand. All right, thank you. And if it's still at a down, we're gonna build another example of the person and a hike. And you'll get to see kind of this implemented all over again. And if you have any questions on that, feel free to ask. Yeah. Final thoughts.
Under the hike.rb file, there is no add hike there, correct? It's just the initialization, which technically does all the work, but there's no other method. So anytime you want to make a brand new hike, you need to do that through the mountain method, the mountain class method add hike, which calls this.
Yes, so right now there's two different ways. If you want to do the add hike from the mountain class, you can call the add hike and it'll do hike.new. If you don't want to use the add hike method and you want to directly do it in console.rb, you can also do it this way where you say hike.new and you pass in poo-poo point and tiger. Both
right,
ways,
but if you're if you're working on an end product, you would be going through the mountain.rb method.
Yes. Yeah, this will be more streamlined because the creator is protecting all the hikes they create. So you don't just want like everyone to be able to create a hike, you want the correct person to be, or the correct class to be able to create it. All right, I'll pause for more questions. Let me clear this out. All right, let's take a look at this new relationship that we have, which is almost exactly the same as the mountain hike, except now it's a person and a hike. And this new relationship says, I am a person and I'm gonna go on a hike and record that inside of our program. I actually flipped this, which is my bad. So this relationship is going to be a person can go on many hikes, and each hike that happens is going to belong to that specific person. So in this case, I can go on a hike technically on many different days and create an instance of a hike for it. Some of the solutions that I saw had like ratings that were added. If you added like a date, then you can kind of log all the different days that you went on that hike with different ratings. So you can get as like creative as you want. At the base of it, we're saying a hike belongs to that single person and a person has many hikes. And similar to what we did here, because a hike belongs to a person, it's going to keep track of that single person that made that hike, rather than person keeping track of all the hikes array. So it's just person is just gonna have that name and location, and hike is going to have the name and also the instance of that whole person that went on that hike.
Can you repeat that again, please?
Yeah, so in this specific relationship, because a person has many hikes, person isn't gonna store that hikes array inside of the person class. Hikes instead is going to keep track of the whole person object that went on that hike. And that also brings on the same point as we did with mountain. You can't create a hike without also having the person exist already. So the people need to be there first, and then the hike is created. So if there's like 5 different friends who went on a hike together, there's 5 different hikes for poo-poo point. I will pause for questions.
There a way that we cannot create the hike without the person? Oh, like to verify that it's there?
Yeah. So in this case, our relationship right now, it's all right that the person needs to exist, because hike's purpose right now is it's sort of just to keep a log of all of the different people that have went on that hike. So that's this relationship right here. Someone's like, I want to record my hikes, and then they create that hike instance.
Okay.
Another way you can think of it, this is like a journal where you're like recording all the hikes you went on, where the person controls all the hikes that are happening.
This one a little trickier though, because I mean, you could sort of flip it around saying a hike has many persons that went on it.
Yes.
So that one is kind of trickier to establish which one is the has many.
Yep.
Okay.
That's why this one's, I'm picking like the one domain for now. You can definitely flip it if you're writing a different example. For us, hike is going to represent an instance of that hike the person did.
So then here we would basically have another array, right, for the persons that have been on it. Or we're storing the person data within the add at all.
Yep, exactly.
Cool.
So this is going to be an instance person. That's the whole object. And then the add at all will keep track of that because it's the hikes class variable.
Yeah. So then I guess within the class hike, we would just, we just have to access that person data and then store that with self.
Store that with, yes, if
add
we
it all,
build
or
in here.
add it all
Yep.
including self. Okay.
Yep. So if we add like the same thing, we have like an add hike in this class. Yep. Then you'll pass itself and add in the hike.
And later, we're going to talk about databases later in the boot camp. So trying to figure out how do we know which way things will work or should work initially, we don't need to worry too much about now.
What do you mean by which way?
Which way, like in terms of which one is more efficient or best? Is it having one hike and many people in one hike? We don't need to worry so much about that because you're telling us this is the relationship, and focusing on how to pass that information back and forth is the more important thing.
Passing the information back and forth, the relationship and who's keeping track of what is still going to be important. Because whether you're working with the database or not, the relationship is going to be exactly the same. The has many and belongs to is not going to change.
Right, so understanding it, but learning to determine it and figure it out, we can wait on that as long as we understand why this is.
I would also focus on the figuring it out part, because part of mod 1 is also getting comfortable with taking a look at classes and deciding the relationship between them. And that will guide us to what's being passed back and forth.
Okay, I have another question then. So say we have this already mapped out and everything works, and then we want to add a hike that also includes the person. If we do add hike from the mountain class, and then we refer it to the hike, will it also pull in the data from the person because it's working on that instance?
Yeah, that's a good question. And that's what's going to lead into our has many through conversation. So what we have here is we have two different relationships that have been set up. We said a mountain has many hikes and a hike belongs to a mountain. Cool. And we also said a person has many hikes and a person belongs to a mountain. Because hike is our common class between the two, which is why I have it like vertical like this, this is our join class between a person and a mountain. So when we define a many-to-many, we say like the has many through keyword, the many-to-many relationship in this case is between the mountain and the person. And I'm gonna go over this and then we'll take a quick break again and then meet back. When we say the has many through and hikes is the join, because hikes belongs to a mountain and hikes belongs to a person has many mountains through hike. So I'm gonna write that.
Do all many-to-many relationships need a join class?
Yes.
Okay.
A person has many, that's an amazing question. They do. Has many mountains through hikes. And then vice versa. Mountain has many, well, I guess like mountain has many people. Skills are super slow. But this is our definition. I don't know why I can't move it. For a many-to-many. A many-to-many relationship is always going to have a join class that's storing one instance of both of the classes it belongs to. So our hike is always going to have an instance of the mountain and always going to have the instance of the person. So now every single time, notice how like mountain is still not storing any information about a hike or even a person in this case. A person is not storing any information about a mountain or a hike. Hike is the only class that's keeping track of the relationship between the two. So hike is still our single source of truth for both of those classes. All right.
How do you,
oh.
Tell me if this is maybe for later. So in order to create a hike, we need to have the mountain first, and then we can add our hike in via the method, the instance method of add hike. But then the hike is created before, but you could also then, in theory, create a person before you're creating a hike. So I'm trying to figure out, what's confusing for me is where does the add hike go? Because you could have a person separate, then you could have a mountain separate.
Yep, that's it. That's exactly correct. You can have a mountain exist on its own. People exist on their own. They don't need to go on hikes at any point in their life and they'll be fine. This hike is only created when a person goes on a hike. That is the only time that this happens. And now when a hike is, oh, go ahead.
Oh, but then how do you connect the two hikes? Because one hike has a person, but it may not have its mountain.
Yeah, so in this case, go ahead. So in this case, we'll combine our hike. So it has a name and it has the mountain object and it has the person object. So we'll rewrite our hike to have 3 properties rather than just the 2.
Okay.
Yeah. And then did you say for the terminology, did you say the hike was the join class?
Yep, the hike is the join. The hike is now the single source of truth. So the single source of truth for the many-to-many is always the class that belongs to both of the other classes. So hike is the join and single source of truth because it's storing the person object, it's storing the mountain object, it's storing the relationship the person has to a mountain.
I guess then by extension, say we add a forest, then would mountain also, could that possibly become a join class?
Yes, it can.
Nice.
Yep.
Okay.
Yeah, if you build it as a many-to-many, definitely can be a join class. Let's thinking ahead. I love it. All right.
So sure.
Sorry, we were. Oh yeah, go ahead.
Oh, sorry. I was just gonna say. So to make sure reword this with a different example, like you could have a restaurant that then has chefs who then create dishes, and the chefs would be the common between the restaurant and the dishes. And then you could expand it out further and say that a city has many different restaurants, and et cetera, on and so forth.
Yes. I'd have to double check what you're storing inside of the table, but in theory, yes, you can have the join class if it's a many-to-many, keep track of all the dishes they create.
Okay, cool. I just wanted to try to reword it with a different example to see if I understood the base concepts.
A little bit. Sweet.
So I guess with that example from Scott, is it saying that the restaurants know the dishes by association with the chefs?
Right. The restaurants have a menu that is created by the chefs. So that would be like the association between the two of them.
Yeah, and then without the chefs, it's like, oh shit, like what's the dish?
Right. A restaurant just can't create the dish on its own and needs somebody to make the items.
Exactly. Cool. I do want to break so that you can have another like rest moment. So let's break for 5 minutes and then we'll build out this whole thing and then I'll answer questions in code. All right. Thank you all. All right, I've resumed recording. Welcome back, everybody. When we left off, we had reviewed what a has many through relationship is going to look like with our person, hike, and mountain class. Before we had kind of an introduction to 2 different one-to-many relationships that we worked with to practice a one-to-many and combined that into a hike. So this is a very unique situation where hike also belongs to a mountain and a hike also belongs to a person. And it's keeping track of the mountain object and the person object because it belongs to both. And that is going to be what a many-to-many situation is going to look like every single time. In a one-to-many, hike stores that instance, you're good to go, you don't need to do anything else. However, in a many-to-many, there is always a join class, and it's going to belong to both the mountain and it's going to belong to both the person. So it's going to have both of those instances in here. So the join class will always be a separate class that's only purpose to represent the relationship between both of the other classes is to store instances of them. And then let me add the name here. And I'll pause there for any questions.
Can you repeat that, please?
Yes. Thank you. So in this case, when we're building out a has many through, our join class, which is the hike class in this situation, is always going to belong to the mountain and belong to the person. So hike is always going to belong to both of the classes. And when we define the has many through, we now say a person has many mountains through the hike class, and mountains has many people through the hikes class. So hikes is storing that relationship between both of them. However, like some of you mentioned earlier, a mountain can exist on its own and know nothing about its hikes, and a person can exist as their own person and know nothing about hikes. So both the mountain class and the person class has no responsibility of keeping track of the hikes. That is in this add-all here.
And I have a question then. So then we can say that a hike doesn't exist unless there's a person to hike on it, right?
Yep, exactly.
Cool.
And the
And
hike
that's
also keeps track of all its own data, mileage, elevation, whatever. Yeah.
Yep. And on top of saying it's not going to exist without a person, because it's the join, it's also not going to exist without a mountain. So in order for a hike to be created, we need to pass in the mountain and the person now. So in a many-to-many, you need both of those instances.
So it's taking both of those instances and then also possibly initializing its own data that you add for the hike.
Yes, and all of this is gonna happen in hikes initialize automatically because we say add-all shovel self. So it'll create these variables and then it'll shovel it into the add-all.
And you can't go on a hike unless it's already created.
You can't, what, a hike?
And you couldn't go on the hike unless it is already created?
In this case, you can, because you can create a hike. However, you also need to pass in the mountain. That's the thing now. Because a person can't just say, I went on this hike. They need to say, I went on this hike on that mountain.
Did you say that in order to create a hike, you need a person in a mountain with it now?
Yep.
Okay, thank you.
Yeah.
I guess the add hike method would, so when you're doing add hike from the mountain class, you're adding on the hike and then it's also taking on the instance of the person that added it.
In this case, yes. Okay. I will say, like, because of the domain that we defined before, it's okay to make it nil. So you can make it like optional until a person like creates it. So that will create some like holes in our data. But ideally, you will need both of those instances there. And it'll also be, you'll see more examples of like a many-to-many situation with that join, where you'll see both of those instances cast in and you'll write methods inside of here and reference all the other classes.
So why did you do like a different square for high, combine all this together and not just combine those two?
Yeah, so this is the combined version of these two.
Okay.
I just made it a new class to represent that this hike is now connected to both a mountain and a person.
Okay.
So I probably should have added I'll add the lines too. But yeah, so this mountain is connected to this hike. Will it let me like, nope. Looks a little weird. I'll organize this a little bit better. But now this mountain has many hikes and this person also has many hikes.
So you can just delete the hikes in the middle, the two.
Yes.
In the middle.
You can delete it if we transition it to a many-to-many. Yeah. So eventually this both will go away. It's going to get replaced with this.
Okay.
Okay. Any other questions?
When you're building out the UML, do you plan on having a combined, or do you do two separate and then go, okay, I can combine these into one?
This will eventually be combined. So in a one-to-many, it's going to look like this. In a many-to-many, let me try moving it, see how bad it is.
But
oh, wait,
Scott,
yeah,
was your question about the architecture point? Like when you're just starting to plan it out, like, you know, you have mountains, like, oh, there are going to be hikes. And that's what that relationship is. And then.
Yeah, that's kind of what I mean. Like what you go like, okay, I'm going to build this out from scratch. I know I'm going to need a mountain. I know I'm going to need hikes. And then I know I'm going to need a person. Do you start by just doing the one, like the belong to kind of thing, and then build it into the through? Or do you just start with the through and call it a day?
You start with the through and call it a day.
Okay.
This looks like super weird. But yeah, you just start with the through because you automatically know that it's a many-to-many. So it'll be like this. The arrows are super frustrating, which is funny. But yeah, so I'm moving this to here. That's my purpose. I don't know why this isn't cooperating. But pretend that's a many-to-many. So person has many hikes. Hikes belongs to a person. And then we can add the person object inside of here. I think Zoom is. Did I hear a question? And then we could say at person, and this is the person object. Yeah, so this will what your initial many-to-many has many through would look like. Cool. Pause for more questions.
Let's see some code.
Yeah, let's code it out. So first step, I'm going to create my person class. I did already add, like, I think I did a person.new right now, so this is going to fail. So let's create our person class first. And if we're following the outline that we've been doing for all of the other models, this is going to be person.new or person.rb. And then let's say class person. And I have a snippet that should autocomplete. Oh wait, no, I'm on my personal computer. Never mind. Initialize, I take that back. And person's gonna take in a name. I think that's what we said. Nope, name and location. All right. I'm slowly getting like all the extensions added on to this VS Code. So we got name equals name, location equals location. And for now, I will, do we want the person to change their name?
Yeah, they can change their name.
Okay, so I'll make them both add or accessor.
I like to change my name based off of what day it is, you know.
It's good to know. You can also edit your Zoom username. I don't know if that.
I mean, you're not ever at Mountain Rescue.
All right, so this should be pretty comfortable being implemented by now. We have our person class, and we decided they should be able to move, they should be able to change their name. So we have an adder accessor, which is our reader writer for our attributes of our instance variables. And in our initialize, we say when a person is created, they have to provide their location. And we have our reader for our self.all that returns the add-all array, which is our class variable that's keeping track of all of the instances of a person that's ever created. Any questions on this before we move forward?
The other array method that we first learned, that was a method array, correct?
Which one was that?
We were storing some local data, and the thing that we don't want to do.
Oh yeah, the hikes array that we did. Yeah, you don't want to store the hikes in here.
Wasn't that like an instance array?
Yeah, before that was an instance variable. So that would be like a person has many hikes, and that would be in here. You want to avoid storing collections, which is why hike will add the person instance in there.
Right, that's why it's the class array that we're looking at now. Okay.
Yep. And let me go ahead. I forgot that this needed a location, so I'm also going to add in a location. I'm going to say, oh, wait, no, we're from Seattle. Sorry, my bad. However, I'm just from Denver. Cool. I don't know. I'm saying these people are from Seattle. We do like New York.
Timbuktu.
Timbuktu, all right. Timbuktu. I think that's how you spell it. I don't know. Okay, spelling is not my forte. But we got our person class. Now, the only way that we can connect our join class is going to happen in the hike. Mountain is not going to know anything about a person. Person is not going to know anything about a mountain. But hike is going to say, I am the join class. I belong to a mountain and I belong to a person. Person equals person. And then we'll add in person. And then we'll say colon person. So when a hike gets created, it's going to take in that person object that went on that hike, and it's also going to take in that mountain. Hike can still count as the log if we add like a date or a rating, whatever extra properties you want to add. But the important part is it at least takes in the 2 instances that it belongs to. So it's going to take in all of the actual mountain instance and the actual person instance. And the main part here, now that we're in our console, is I can't just say add hike and pass in that hike anymore, because hike.new takes in one more extra parameter. It takes in that person. So mountain would also need to take in the person that hiked it if it wants to add that hike, which could be like the initial person that hiked it. For now, let's try creating a hike without the add hike and see what it would look like. So even this, our hike.new, is going to fail because our person doesn't exist yet. So this is the main thing I want to point out. Whether it's a one-to-many or whether it's a many-to-many, when you're creating that belongs to class, in this case, it was hike for the one-to-many and the many-to-many, before we passed in the tiger instance, we said the mountain had to be created. Now we also need to pass in the person instance, so the person also needs to be created. So the mountain and the person needs to exist. I'll kind of let this sit here so you can take a look at it. Let's see, Psy, and then the last one was Pilchuck. And this could be Bob. These are all poo-poo point, but let's do 2, oops, 2 and 3. So in this case, like what you name this doesn't matter too much. But the main part is there are now 3 different people who have went on poo-poo point. I think it would make more sense to make all of these tiger because poo-poo point is on tiger forever. So there's 3 different people who went to hike poo-poo point on Tiger Mountain. Even though it's at the same location, because maybe we went in a group, maybe it was individual, we'll know if we add a date here. But there's 3 different instances of that hike, and they're all unique. So I passed in the mountain and I passed in the person. Now let's see what that would do. If you have any questions, let me know. Ooh, fun. Why is this happening? So I got this uninitialized constant person. What does this typically mean for us?
Did you link all the files together?
Yeah, I remember linking hike and mountain, but I forgot to link person after I added it. Yeah, anytime you see uninitialized constant, it just means that class isn't available. And you'll get the same error for a gem too, which is what you see for pry. So whether it's a gem or a class, if you don't require it, it's gonna error out. All right, so we made it to the end of our file. That's one good sign, since it didn't error out. Now, if I say hike.all, it's gonna look a little bit different. Because we defined the hike to be the join between two different classes now, hike keeps track of the mountain, which is the whole mountain object, and hike also keeps track of the person that went on that mountain and hike at that point, which is Sandaria, Ahmad, and Bob. So we have 3 instances of a hike that happened maybe on that day, but by different people. Now I pause here for questions.
Where did their location come from?
Their location is something that is in the person class.
Oh,
so
okay.
when we create a person, when we create a person, we say this is where they live. So we added that as a location in the person object, which is why you'll see it nested in the person object.
If you were to add yourself to go on Tiger Mountain again, it would still be another unique instance, correct?
Yes, it will be. Because if we add a date, for example, in our hike class, it'll be on a different day. Maybe even if you do it like to the hour, it could be a different hour. You're like, yeah, I went and hiked Pilchuck magically in like 2 hours or something, and then tried it again at night. I don't know. It's like beast. And then similar to right now, we just kind of did the hike.new from here. And just like some of you mentioned, also start thinking about what if I did now create, I guess it would make more sense for like a person to add a hike, and they would also need to keep track of the mountain that hiked it. So in our person class, when we're creating a hike, we also need to figure out a way to get the mountain. So typically something that you can do is maybe write a method called find mountain that takes in like a name. Then there'll be like multiple ways to write this. And in this case, name is going to be the mountain name. And as always, with any method that you write, always be thinking about what's the variable that's coming in, what's the variable type, and which class do I need to talk to get that information, or classes, and what's the data type returned. And in this case, the class I need to talk to, which one is that going to be?
The hike class?
The hike class, I'm creating a hike right now. So a person is saying, I want to create a hike. So that instance of a hike is not going to exist. And I want to get the mountain object. Yeah. And specifically when we are talking to the mountain class or any other classes are referencing each other, it's typically going to be the add@all. So I'm going to say mountain.all. And this is where you can write some kind of algorithm. Find the important part is I'm going to use this find, why did I say find mount? And I'm going to use this find mountain method to create a hike later on. So I can find the mountain first. I need the whole object itself so that I can pass it into the hike. So that's the main thing here. We need to return the whole mountain object. So find the mountain object that matches the name. Cool. And then return the mountain object. And the reason I put this in a separate method is so that we can practice single responsibility principle. So you're not trying to do too many things in your hike class. And then in add hike, this is where I am associating a person with a hike. And then let's say add hike, I need the mountain name. So I'm going to take in the mountain name. In this case, I'll be a little bit more explicit. I guess I could say mountain name over there. Mountain name. And then I'm also, I need to take in the hike name. In order to create a new hike, I need a name, I need a mountain, and I need a person. You also always want to be paying attention to which class am I currently in, because anytime you're creating that association, you're going to be using self in some form to connect them. So I'm in a person class, and this is an instance method, so self is going to be that instance. And in the add hike, I want to associate the person with the hike. I now have a mountain name, I now have a hike name, I now have self. So I should be able to create a new hike association. So create a new hike. So you can say like hike.new and pass in the proper arguments.
Which would be mountain name, hike name, and self.
Yep, exactly. Mountain name, hike name, and self. And the reason that I'm explicitly commenting instead of writing the actual code out is for you all to try it, and then we'll reconvene later today and go over it. So try to write out these two methods to associate a person and a mountain together, or create a hike with mountain name and hike name. And association, whenever you see this word, it's basically us creating that join or creating that instance that connects both of the classes, so the relationship between two of them. And in this case, because we know hike is the join, we're going to be creating a new hike. Pause for questions. Right. So got an introduction to a many-to-many relationship and how it's represented. You might notice it's pretty similar to a one-to-many relationship-wise, because this still belongs to both. And when it's the join class, the only difference is it's storing both of those instances instead of just one of them. And the cool part is because hike belongs to a mountain and a person, it's directly in line with the belongs to class, always keeping track of that instance where we have the out mountain and at person in this class. And it is pretty common sometimes that it's just the hike's not really doing anything. It's just keeping track of all of the instances between these two, which is all right. All right, and at some point today, I know you're working on the Paralab. We'll do a review of this after the Paralab today, so I'll just like have everyone hop into the main room and we'll implement this out together. I want you to kind of give it a chance. You can take like a couple minutes and write it out with your partner too if you want to when you're working together. Otherwise, as of this, for the code challenge, it's going to be pretty in line with what we've done up until today, like setting up relationships, figuring out like what's the join? Is this a many-to-many? Who's keeping track of the instances? And writing methods like this to figure out what variable is coming in, which classes do I need to talk to? What does the return type need to be? And getting more practice understanding it and debugging these value types. There should be the practice challenges released, which you can start kind of taking a look at them and start going through. The baking object today or banking pair programming will also give you more practice. I don't have like the calendar open, but that should also give you more practice to work through relationships. And yeah, any other final thoughts or questions? Wait, let me